Hi everyone, welcome back to my channel. So in today's video, we'll try to dive into polynomial regression with gradient descent. And of course, I will provide example with a step-by-step with numerical example, small numerical example. So in the last videos, we see how the linear regression is working. But as you can see here, for instance, you can see this diagram here. uh, the data, let's say, is distributed with this way here. And it's not, let's see, easy to find the best fit with linear regression line. So the linear regression line is, for instance, for this equation here. But I mean, I already explained this in a very detailed way, so you can have a look in the previous video. And as I said, the data, I mean, you can't, let's say, draw a line that can cross for maybe cross the all data here with a linear with the line. So the next solution for this is we can use polynomial regression. So the polynomial regression, it's for instance can pass through this data here. And as you can see with this information here, we have, for instance, B0, beta 0 and beta 1 plus x, I mean, multiplied by x1. And this is the square. We will add this to the equation, so to the data set. We will have example and it will show everything here. So when we would like to use a polynomial, so when your data, it's not, it's, let's say, complex and hard to find the line that cross the all data here. And sometimes the interaction between features could also make the prediction or the model is perfect. So we can use the polynomial. For instance, if you see, I have x1 here, and instead just of x1, I just add the x1 mal x1. And you can also combine many different features. For instance, x1 multiplied by x2. And this x1 and x2 are features from your dataset. We will go through this example, and don't worry. And when we need to use also when our data, it's not non-linear. So as you see it here in this example here, the data is distributed in a different ways, so it's hard to find a line. So in this example here, I will try to make it, let's say, short, because everything here is already explained. Only the periodic quadratic polynomial equation. So I will use the same data set here. As you can see here, this the weight, the age, and I mean height, weight, age, and weight. We try to find the best value or predict the right value for the weight once we have, let's see, height and age. But in this example here, I try to, let's see, to remove this, but it's not needed to remove any parameters here, any attribute. It's just as an example here. So instead of age, I just add x1 multiplied by x1, the same stuff. It means uh, height mal height. And this is only one example. It could be also possible to see y is equal beta 0 plus beta 1 multiplied by x plus beta 2 multiplied by x1 and x2, for instance, height and age, and plus blah blah blah. And this is only an example, so don't worry. And let's say just we need to define, this is the problem, and we try, this is the y, it's the weight that we would like to have. So as you can see here, I have, this is the same data set here, but adding another column here, which is the square, the quadratic polynomial. And it's the same as I said in the beginning of the last video of the linear regression. We try to initialize this to 0. I mean, these parameters, all parameters are initialized to 0. Then we have this equation here, the cost equation. We're using here mean square error. We also discovered this in covered this in the previous video as well. And this is the gradient descent update. So this is a beta 1, this is beta 0, beta 2. And this is only to calculate the gradient. And to update the weights, we use these equations here. So as I said in the beginning, if if you need to be familiar with this stuff, you please go to the previous or let's see linear regression video. I will try to add it in the description. And this is, for instance, in the iterations 2. So after having the calculating, for instance, the B0 and B1 and B2, the new values of these values of these attributes, we need to add, for instance, it's really simple example here. But as I said, just go back to see the video, and we have to iterate this until we, let's say, reach the best fit to our data set. And let me just there are some advantages and disadvantages of using polynomial. So the polynomial, I mean, flexibility, it can be used for a wide range of relationships. So to relationship between the features. For instance, here it could be between height and age, height and some other parameters. Let's see. And yeah, and what is the disadvantage of this? Sometimes it could be somehow overfitting. As you can see, for instance, if we use a linear regression, for instance, this one here, right? And you can see it's cross. I mean, the data it's not, let's see, fit because it's not, let's see, a linear distributed. And if you increase the degree of polynomial, it for instance 3, you can see 3, it means, for instance, in this case I use 2 square, and 3, and you can see 3, it's somehow 3, the red one, it's better than the linear one. And when you go down and, I mean, increasing the linear polynomials degree, for instance 9, it will try to fit to pass through this data here. But now, this is called overfitting. It will try to memorize all the data set in the training set, but once you have a test set, for instance, assume that we will have a point here. So it will be not predicted well because it's far away from the, the line. And this is another one. As you can see here, if you use the linear regression, most of the data is far away from the line, this line here. And here, if we use a linear polynomial degree 4, you can see somehow it's better. But if we use degree 20, it will be overfitting. And overfitting, it means the data set, the BOM model is working perfectly with the training data set. But for the validation or testing, it's working worse. So it's not working well. So I mean, we come to the end of this lesson. So as you can see, I spent much time to prepare this document. So I will also try to share it in the in the in the description and give you a link to this. And also for the Python code, it's also doing the same as this file explained. So if you would like, also you can run use this code to run one. To run the explanation. So it's the same as I have explained here. So it will help you also to debug if you would like to debug and see what are the values of each variable and what are the, yeah, and also this will be attached also in the video in the description. And if you like this, please subscribe and hit the bell button and also like the video. And if, of course, if you have any question, just write it down in the comment below. I will answer it. Thanks for watching and see you next time.